Welcome to Chapter 9. The topics, as you can see, are mole ratios, stoichiometry, percent yield, limiting and excess reactants. You're already familiar with mole ratios. That's what this video will be about. That's the coefficients when you balance the chemical reactions. Stoichiometry is simply figuring out if this much reactant goes in, how much product should come out. Percent yield is very similar to that. How much are we actually getting out compared to what we expect to get out? And then limiting and excess reactants is looking at the ratios that reactants react in, which one will run out first, which one will be left over. So reaction stoichiometry, the quantitative relationships among reactants and products in a chemical reaction. Like I said a second ago, it's basically if this much goes in, how much do we expect to come out? If I have 10 grams of reactant going into the reaction, how many grams of product should come out? So that's what you'll be able to solve when we learn how to do stoichiometry. Now the mole ratio is the conversion factor that relates the moles of reactant to the moles of product. It could also relate moles of one reactant to moles of another reactant. So you're actually already familiar with these. It's the coefficient of moles. It's the coefficient in a balanced reaction. So the coefficient tells us how many moles or what the mole ratio is. So it's the same process as last chapter, balance the reaction. And then once you have it balanced, the coefficients become your mole ratio. Sorry, I'll let you write that down, pause, and then we'll move on here. Okay, now we have a reaction here. It's a decomposition reaction. I've got aluminum oxide decomposing with heat. Remember, this means heat to aluminum and oxygen. Now to balance this, my oxygens, I'm going to put a 2 here and a 3 here. That gives me 4 aluminum, so then I put a 4 there. So these coefficients that I just wrote down, these are my mole ratios. They are a counting number. What this means is that 2 of these things will decompose, 2 of them, to make 4 aluminum atoms and 3 oxygen molecules. So 2 of these go in, 4 of these come out, and 3 of these come out. That's what it's saying. Or I could say 2 moles of this goes in, 4 moles of this comes out, and 3 moles of this comes out. So that's the counting ratio that we've got. So you'll see questions like this. What is the mole ratio between aluminum oxide and aluminum? We've got aluminum oxide. There's 2 of these. And there's 4 aluminum. So it's a 2 to 4 ratio, which could be simplified if you would like to a 1 to 2 ratio. Sorry, that 2 got messy there. So balance first, we already did that. What is the mole ratio between aluminum and oxygen? The mole ratio between aluminum and oxygen is a 4 to 3 ratio. So I just used those coefficients. It is a 4 to 3 ratio, which cannot be simplified. And then what is the mole ratio between aluminum oxide and oxygen? Well, that one is a 2 to 3 ratio. And what we should actually get into the habit of doing is writing this out as 2 moles Al2O3 to 3 moles of O2. So it's a 2 mole to 3 mole ratio to keep track of which compound is which. So I'm going to move on here. We're going to do one more problem for this video. It says how many moles of aluminum will be produced from decomposing 13 moles of aluminum oxide. So it's asking how many moles of aluminum. So let's just isolate that, put a question mark there. That's what we're trying to solve, right? How many moles of this are going to be formed if we decompose 13 moles of this? So it says you're decomposing 13 moles of aluminum oxide. So we know that if 2 moles of this goes in, 4 moles of this comes out. So basically, however much of this goes in, we get double out, right? Because it's a 1-to-2 ratio. So you could look at this and say, okay, well, if 2 goes in, 4 comes out. Well, if 4 goes in, 8 would come out. Or if 13 goes in, 26. Whatever goes in, double of this comes out. So you could quick solve that probably without actually doing any math. But I do want to show you how to use the ladder because they are super important. And again, like always, the ladders are going to get longer and they are necessary. And you got to show how you're canceling your units. So make sure you do use the ladders. So we always start with what we're given. In this case, it's 13 moles of aluminum oxide. Now, just like we've always done with ladders, you take the unit, moles of aluminum oxide, Al2O3, and bring it down. Now, in this case, it's asking how many moles of aluminum. Okay, so we're going to moles of aluminum. There's one big change here that we're going to be making. In the past, the mole has always gotten the 1 when we set up a ladder. No matter what, wherever the mole is, you just put a 1 in front of it. That's still going to be true for some of the scenarios, but there is a scenario now where that is not going to be true, and this is the scenario. Whenever you have mole above mole, you have 2 moles in the same step of the ladder, it does not automatically get 1 anymore. It may be a 1, but it's not automatic anymore. Now, whenever you have mole above mole, this is your mole ratio step. This is where you go up to your equation and you figure out what numbers go here. And the numbers that go here are the coefficients. So this is why I have you write the compound in every time, because now you keep track of, okay, moles of aluminum oxide. Okay, I'm on this compound here. The coefficient is 2. There's 2 moles of this for every 4 moles of aluminum. So if you don't put the compounds in here, you're going to just end up guessing which one goes on top and bottom. But if you put the compounds in, then you don't have to guess. Also, you will get dock points, so just put the compounds in. Now at this point, moles of aluminum oxide cancels. 13 times 4 divided by 2 equals 26 moles of aluminum. And that's my answer to 2 sig figs, because this has 2 sig figs. So that's how you do the mole ratio, convert from one thing to the next. And obviously if you're going to oxygen, you just put a 3 on top here instead of the 4 if you're going to oxygen instead of aluminum. So that's intro to mole ratios, and I will save this problem for the next video.